or the oven calls it heat. There's solder and then a cool. So what this will tell you is, okay, the preheat temperature goes up to, hang on, let's see, is there
110 seconds?
I thought there was a chart with this one as well. Anyway, so yeah, you can look at this and you can say, okay, that goes like to 140 degrees, 145.
Yeah.
So we'll set the first time at 120 seconds to that temperature in the oven. And it's already programmed for this. So you shouldn't have to change it, but you should always double check your settings to make sure that it hasn't changed.
Okay.
Then there's this period, which can be soak temperature go from 140 to 180 for 60 to 90 seconds. And that's where the flux will activate. Then the reflow time is only 30 to 60 seconds with a maximum temperature of 220 top side of the board, or 230 or so. But you really have to look at it to make sure that you're not exceeding what it calls for, because we want to use as low of a temperature as we can get away with. Because the higher the temperature, the more risk of damage. So let's go over to the oven. You look bored out of your mind. But, so, this is our reflow oven. We put it in here because it has an exhaust fan on the back and it stinks. There's a physical power switch back here you have to throw on. Then you turn it on. So you'll have maybe, like I've taken a picture of that reflow chart and then I brought it over here to program it. You can read the manual for this, but use your display here and you can go into either solder or repair modes. Repair just heats it up and makes it warm enough at a warm temperature so it's easy to work on things. We don't care about that. We're using solder. So if we hit set when we're on that, it'll drop down here. And so right now it says preheat. 140 degrees, 2 minutes. We hit down when it's selected on this, it will take us through the different stages. Now it says 180 degrees, a minute 15 seconds. Down again, there's the solder, 220 degrees, 1 minute. Go down again, this has a keep temperature where it won't turn the cooling, the exhaust, it has a cooling fan in there. It won't turn that on until it drops down to this temperature. So that's just to help it start to like crystallize slowly without getting shocked. And I have that set to 5 degrees below the solder temperature. And we've been experimenting with some of these, so sometimes it's worth putting a crap board through to make sure that nothing's, that you've got it right. And then there's the cool down temperature, which will take it to 140. And when it goes into cool down mode, it will actually, there's an exhaust fan on the back of here. And it will actually it'll start drawing cool air through and cool it down. So once that's right, this is all right. Or if you needed to change it, when you're, like, say you had to change this, you hit set, and it will take you over to the temperature. Set will take you over to the time. So we can just exit out of it. So once it's on, and it says solder up here, when you're ready to go, you just hit run. And we'll go through this. This is where I burned the board. So you'll put the board kind of in the middle here, and gently put it back in, because if you push hard, all those things are just sitting on there. You don't want to knock them off. Put it in, you'll hit run, you'll wait till it finishes.
How do you know it's finished?
It'll go through and it will show you what the temperature is inside. So we'll get to that. But the stuff should be warm enough now. So, like I said, I had been using, to make it cap, because we don't have caps for these, I've just been leaving the old tip on there. That way the solder in here will dry out and it will make a plug. So this is garbage, and we'll get a new one. And we've been using the blue ones.
What's the difference between those kind of colors?
The size.
Oh, the size.
So if you look at the size of the needle.
Oh, okay, that's more.
So you get better flow of the solder through a bigger needle, but you get more solder and it's hard to be precise. So it's kind of a balancing act. So these just twist on. There's a port on the front of this device here that has the blue thing in it. You just kind of push it in and it will lock it in place. And if you need to remove it, you push in on the blue and then pull the thing out. It's like a Chinese finger trap. So put that in there. Then you'll go and turn on the air pressure to it. I've had good luck at about 90 psi, so this knob right here controls the air pressure internally. So we'll turn the air on, and you'll see that jump up to 87 or so, 85. And there's a foot pedal with this. So it's just, if you've ever used a sewing machine, same thing. And this device can be set to automatically dispense a metered amount of solder, but this is sort of a cheap knockoff, so it's not that good at it. I found it much easier to just do it manually. So it's set in a manual mode right now. So this time dial does nothing. When you have your foot on the pedal, it's pushing, and you let go, it stops. So,
where do you see the menu?
What's the pressure line?
What, the menu? There are dip switches on the back.
Oh, okay.
There are dip switches to set that.
Okay, all right.
But it just works better in manual mode.
Okay.
So you'd have to get the manual to see.
Yeah.
But
Menu is online?
and we have it here too.
Oh, where's it?
It's up.
Up there. Okay, good.
I thought it was. It's not up here. I'll find it.
Sure.
But for the most part, I've tried the automated settings, and it's just too inconsistent. It's a really rudimentary circuit. I think it's a 555 timer.
Sure.
So we can turn it. We'll turn it on. Oh, I'm sorry. To switch between auto and manual, it's not the dip switches. It's this green switch here.
Oh, good. Not better.
Auto or manual.
Okay.
But the dip switches set your timing, some of your timing constraints,
Sure.
and then this sets.
You don't use it right now?
I don't. I've had such bad luck with it.
That's for auto.
Yeah.
Okay.
When you're in manual.
The auto this together.
Yes.
In the menu doesn't matter.
Yep.
And this adjusts the
Air pressure.
Okay.
So pull it out to unlock it. Turn it up or down.
Mm-hmm.
But I think we're locked in at probably the max that will deliver.
Okay. Put it back. Okay.
Yep.
All right.
And that locks it. You can set a vacuum control so that it will pull. Sometimes what will happen is when you let go, it'll keep oozing out a little. The vacuum control can help with that, but it's not great. And so this actually creates a vacuum to help stop it.
Back. Okay.
I found that I don't really need it, but if you're having problems, that can be a big help.
Yeah.
So,
To demonstrate the whole process.
I was in the library doing a group with my.
Actually, this is cool to know this.
in general, when you're assembling stuff like this, like I said, when you first get a board in, you should do a test fit. So before you go putting everything on, you want to make sure that you made your parts right in the board. Because you don't want to get halfway through and realize, oh shoot, I screwed up. So, like in this case, we've got our RJ12. I'll put it in there. Don't want to bend it. Great, that fits. These can be a little tricky, but and really it's the through hole components that we're concerned with. Anything that has to fit through, fit through holes. LCD we're not using, so we don't care about. Here's one of the fiber optics. So we'll go and okay, that fits through the holes, because if you make your holes too small, that happened on on the other board. There were a couple that were just a little too small, so the pins don't fit through. Then you have to figure out what to do. So that fits. It's a little tedious, I know, but you'll save yourself a world of hurt if something is wrong. And you should always, when you're dealing with all these little components, they don't have labels on them, but only take one component out at a time. Then put it back in its bag and move on to the next, which I didn't do. Put these back in. These are fairly self-explanatory, but so you're going to see some things like this that come in this static or this moisture sensitive bag, and they'll all have like a sticker or something on them. If you're doing by hand, there's no concern. If you're doing it in the oven, you want to wait to take these out until you're ready, because that device isn't hermetically sealed, so moisture can get, humidity can get inside of it, and when you turn it up the temperature up that high, it will actually boil inside, and there's humidity, and it will boil inside the device and damage it. Which is why up until now we've never cared about these, but now that we're doing the reflow, you do. In this case, this is a hand soldered component, so I really don't care. And they will come with a desiccant inside. So when you're storing them, you should seal them back up in the bag, put back in there, and they'll come with a humidity card, so you can get an idea of what the humidity is. And they, in theory, have to go through a baking process. If they're out for too long, it'll probably work even if you don't, but you could run into a problem. So we'll take one of these, see if she fits. Uh-oh. That could be a problem. So it looks like my holes up here are too small. I made them a little bit too tiny. That's why you test fit. You can see this. I think is just a hold down. Do you know these two front pins? I think that's just to hold it in place. So what could have happened is when you make a hole, if you see in there, you see the silver inside the hole? Mm-hmm. It's called a plated through hole, or through hole plating. So you drill, this is silver. You drill your hole, they drill your hole to a certain size, but then they put solder on it to plate it all the way through. So it's a constant connection. That solder takes up a little bit of space. So in this case, I didn't make these holes big enough to account for the solder. Okay. Oops. It's the kind of thing that it's hard, you try your best, but mistakes happen. Yep. So what we can do later is we'll try and melt that solder and see if we can push this piece in. Okay. But these are a little tight for comfort, to be honest. I'd like them to be a little bit more loose. Okay. And that's, you get a board, you try and put it together, and then you can go back and say, well, here are my mistakes. Ideally, you don't want to make the mistakes, but you need to keep note of that. So, there, and then this was the last one. Mark, could you do me a favor and get the big bag of gold headers from the drawers? You know the big bag we've got? So in this case we have two components that are the same, right? They're just different, the same footprint. So we'll put that in there. Oh, and thankfully that fits. Okay. Now on this design, he didn't put any, actually we'll grab the finished one. He didn't put these mounting holes in. So if you look here, see how those are See how the blue one is sticking up?
Mm-hmm.
And it makes it very unstable.
Yep.
See, so anytime they do this, they're afraid of breaking it. And what you could do is you can actually put another hole where in this case, where this one is, and put a screw through to mount it in. We aren't going that far, but this piece can actually separate from that diode that's underneath, which is why you would do that. But you do want, having those mounting holes there, make it so that it's firm. See, when you're putting them in, if you were feeling a bend and twist, that prevents that. And then we'll just try the other one to make sure it fits as well. Fits. So we've just got that one that has a problem, I think. And then we've got... So a lot of components use a standard pitch for headers. So we'll just make sure that it fits. Okay, that's right. This isn't a header, this is a voltage regulator, but it should be the same pitch. And this is just a one-time thing to save yourself headache later. Mm-hmm. Okay, my headers, they all fit. They were done right. Oops. Off to the side. And this really doesn't take nearly as long as it seems like it is, because I'm explaining every little thing. Any questions so far? Okay. Away. That's through hole, that's through hole. Surface. Oh, these are 0 ohms. We got a big collection of 0 ohm jumpers. I ordered 250. So they're cheap. It was $2.60 for 250. So what I'm doing right now is I'm separating my through hole just because there's a lot of stuff. I don't want to have, this is all through hole stuff. It just gets in the way. We'll set it to the side because we don't need it. Yeah. Okay. Get a board. Oh, could someone run and grab me a hunk of paper towel? Thank you.
Do you need to trip the connection with the board?
No. They do that in manufacturing. It's not a guarantee. For a full electrical test, you do pay extra, and they'll check every single thing. But they do go through a visual inspection, and they're not guaranteed to be right, but our tolerances here are really big. Mm-hmm. You know, we've got big spacing compared to some of the really tight. Oh, why did he go out? There's some right in there. Sorry, Sean. So we're just, you could, but it's an awful lot to do. So, I just, there's a roll in there. Or there was. We got it over. Sorry. Oh, he brought it over. Sorry. So we're just going to clean the board real quick. Use the alcohol paper towel. You don't want anything boiling, like if there are oils. You ever used a halogen light bulb, like for a car? They tell you not to touch the bulb with your fingers. Theater lights have the same thing. They get so hot that the oil will actually boil on the glass. When it boils, it will cause the glass to boil. And they'll turn silver and get really big. So we just want to clean off anything that that's on there that could cause a problem. So just give it a quick clean. Nothing special. So since we have a double-sided load, we're going to start with the back side, because that has all that's on there are passive components. So, oh, this likes to leak sometimes. There. So it takes a while to force the solder out, but you see how it just started to ooze out that little bit?
Yep.
Yeah. And when you start, if you just try and lay it on there, it will try and stick to itself, and it's not very good. You actually have to, when you put it down, you actually have to kind of put some pressure on and let it push it, almost push it into the pad. So if we do that, if I just try and like do this and drop it on, it doesn't work very well. But if I go and I kind of put it on there and let it ooze out a bit, you can, I'll take a look, but do you see how it stuck to the pad well?
You push it, and did you release or use?
Yeah, no, I release.
Push and release.
Yep. I keep it down there for as long as, until I'm happy with the amount of solder, then I release. Okay. Or just before.
Okay.
That takes a little bit of practice.
Yeah, right, looks like.
And you don't need much solder. It's easy to get too much. One thing that you need to be aware of, especially with the resistors and capacitors, is an effect called tombstoning, where if you have a lot of solder on one side of it and very little on the other, there's a lot more surface tension on one side than the other, and it will actually physically pick the thing up and pull it, and it will flip up like a tombstone. That's a pain in your butt because you got to go back and fix it, and you don't like it. So now that we have this all sorted out, and we will need an assembly guide, so I'll pull that up in a minute. But so I'm going to go through here and put. Why do you keep leaking? Need a better one of those. There we go. And it's nice to have paper towel to clean the goop off the end. Smaller components need less. And some of that is practice. Figuring out how much. Which is why some junk boards that you can just play with are helpful, because you can experiment.
All of them, huh? All of them.
What? Yeah, I go into all the pads on the side.
Okay.
This stuff has a working time of a couple of hours, so you've got plenty of time to work with it. Let me. And if you see the bigger pads, I'm putting a little bit more solder on.
So the way you determine how much solder is?
Unfortunately, is just sort of practice.
So the more you hold the pedal, the
longer it keeps coming out.
Okay.
Yep, it's just if you've ever used a sewing machine, it's on and off.
Okay.
What you can set it to, if I just click it
Can
once.
you automatic set it?
Yeah, but that's what I'm going to show. If you click it to auto, and now I click it once. And this dial adjusts that time. But I prefer to do it manually. I get better results.
Okay.
So I just leave that in manual. Sometimes you might screw up and have to clean it, or worst case scenario, wipe it off and start over. It doesn't take long. Okay, so that looks like it is all of our surface mount things in the back. Now, because we're doing this on the back, we need glue.
Oh yeah.
So, and we'll get to that thing. Glue, this Loctite uses the same tips. And I want a really fine tip. Where'd the... I think I brought one from home, but... Did I toss it in here? Orange or which one's... Okay, so the orange one is a little smaller. And the glue's going to have an easier time getting through it. So I want a really fine tip. So we take the caps off. In this case, it uses a bigger size. So we'll plug that in, lock it. Unplug that one. Plug this one in. And we're going to put just a tiny dab of glue on every component. But
So
first,
after the base is the glue. Right.
If you on the back.
It's only for the back because you're going to flip it.
Oh, okay.
and one thing you might find is if it's coming out too fast, you would then
Air pressure.
reduce your air pressure. Because we only want a tiny little blob. And that's why I always get it figured out with paper towel first.
Yes.
So I'm going to go through here. And
Is it right in the middle or the side?
kind of in the middle, but on the edge. So I'm going to put... Doesn't need much. Because it's gonna squish out when you...
Can you see it?
Yep. That might even be too much on some of those. But
Okay. Like when you heat up, it won't melt.
it's a thermally cured epoxy. So once it cures, it won't melt again. Okay. So when you heat it up the first time, it will dry, and then it won't melt ever again.
And this thing is not dielectricity. I mean, it's not conductive.
No, it's non-conductive. Okay. It's called a chip bonder. It's specifically made for this purpose.
Okay.
So that's used only for a two-side board?
Yes, it's only for a board that has components on both sides.
Okay.
So we're going to go through here and... That one we can put a little bit more.
So you put it on all the pads?
No, side of the middle.
Kind of in the middle, or off to the side in the middle, whatever.
Not on the actual pads?
No.
Okay.
All this is doing is going to hold the component in place when it melts again. Because the solder, when you flip it over, is going to melt. And in general, the surface tension will hold it in place, but you don't want to take that risk. So you want to make sure that the component is locked in place,
Okay.
so it doesn't fall off.
Right.
Okay, so we're going to... Oops. I didn't expect these to be this long. I don't like them. But, well, that could be it. We'll see. And if you find it easier to use a magnifier, go for it. I find them get in the way more than not. Okay, there we go. So now we've got everything in there. We're done with this, so we're going to seal this back up so it doesn't dry out, because this tube is like $40, I think.
Oh my god.
It's an expensive glue. This is trash. Once you're done with the tip, it's garbage. They're not...
Same thing applies for the solder base?
I'm leaving because we don't have a cap for this. See how this one has a cap? I'm using the tip as a cap, so I'm leaving it on there when I put it back, and then I throw it away when I start the next time. Just so the solder doesn't dry out. So we're just going to tap that back up. Come on. Now, can I get over here? You're you're going to need some sort of diagram to tell you what goes where. You know, what component, either bill of materials that tells you each component designator and what value it is, or whatever. Or even just the circuit. You know, if you're in the schematic, you can look at the designators and the value, and you know, I haven't tried this before, but we'll see. Okay. Assembly drawing. I don't know if this will be useful or not. Nope. But you could send a drawing like this to an assembler so they could see where everything went. So let's see, bill of materials. Are you going to be helpful? That might be more of a pain in the butt than it's worth. So this will tell, you know, this will show me all of, all the components and what they are, but yeah, we'll go with that. So you could print something like this out, or just have it here. Let's actually sort by description. Okay, so I like to start from one side usually and just kind of work my way across, but not always. Tweezers, your friend.
Okay.
So let's just start out R2. Let's find R2 on here. R2 is a 300 ohm resistor, so we've got to go with crystal. And you'll kind of figure out what your components are as you go.
So when you put components, you start with the smallest one or the biggest one?
Neither.
Or it doesn't matter?
Just kind of what resistor, 300 ohm. For these, I'd like to tear a little hole so you can put the thing back in. Because again, with resistors at least you can read the value. With capacitors, there's no value marking.
Once you put the solder paste, do you let it dry? Or
No, you have a working time of about 2 hours
oh, okay.
once it's on. So we'll go here, and we will. Oop, come on, get out of there. We'll take our component out. This is the only one of these, so put it back in here. And if I know I don't need them anymore, I kind of move them over there, get them out of the way. So we'll go here.